Hello, we are Team 58 of Texas Instruments Analog Design Contest from Netaji Subhas Institute of Technology, University of Delhi.
We have worked under the guidance and mentorship of Professor Dhananjay V. Gadre. Our project is entitled as Accident Prevention Unit. We would also like to extend our great thanks to Texas Instruments for giving us this great opportunity.
Our project basically monitors the driver parameters which most prominently lead to road accidents around the globe. If an alert state is reached, then the driver is intimated about his situation. The vehicles around the driver are also informed of the situation using an external display shield powered via the vehicle. And if the driver does not recover from his situation, then a message is sent to his next of kin so that they can take necessary preventive action. We have made a 5V 1A power supply based upon the LM723 IC by Texas Instruments for voltage control and current sensing. This power supply will be driven using the vehicle itself for powering the alarm display shield, which will be present outside the vehicle. This is the sensor framework that we have developed for mounting on the body of the driver. It consists of an enabling sensor attached to a detachable arm of a pair of glasses, a headphone unit on which an accelerometer and an alcohol sensor is attached. The sensors involved in our project include an MQ2 gas sensor for flammable gas detection, which includes alcohol, an MMA7760 accelerometer for head tilt detection, and an eye-blink sensor which consists of IR LEDs, and an LM358 operational amplifier by Texas Instruments, and a 10K potentiometer for auto calibration. We have developed this ourselves. This is an alarm display shield that we have developed for mounting outside the vehicle to intimate the drivers around the vehicle that the driver is in an alert state so that they can protect themselves as well as the driver. This will be powered using the vehicle itself using a relay. It also consists of 4 7-segment displays and a push button. The relay can also be used to shut down power to the vehicle when the driver reaches an alert state. This is a generic 8 ohm speaker which will be used to sound an alarm to the driver so that he can return to his previous alert state and escape the alarm sequence. These are the components of the GSM module that we have used to communicate with the driver and a relative of the driver in case an alert state is reached. This is the Texas Instruments Stellaris Guru microcontroller unit that we have used in our project. This was developed at CEDT and SIT. It consists of an ARM Cortex M3 based LM3S608 microcontroller by Texas Instruments. As this board is based upon the Arduino footprint, we have developed an Arduino size shield to interface with the device. This is the Arduino size shield that we have developed for interfacing our sensors with our TI Stellaris Guru microcontroller unit. Now we test the entire device in its working state for the presence of alcohol in the driver's breath. The entire device has been attached appropriately, and the sensor framework constantly monitors the state of the driver and tests for head tilting, presence of alcohol, and closed eye state of the driver. Just as alcohol is detected in the driver's breath, the alarm sequence is triggered. The help signal is generated, which is shown outside the vehicle for nearby drivers. The UART terminal of the computer verifies the fact that alcohol has been detected. And just as the alarm sequence is triggered, an SMS is sent to the relative of the driver to inform them of the urgency. As can be seen, the entire process occurs in a matter of seconds, and hence mitigation measures can be taken to immediate effect. We have devised an intelligent algorithm to detect the closed eye state of the driver. The algorithm monitors the driver's eye state for 6 seconds, and if it is found to be closed for more than 4, then the alarm sequence is initiated. The eye blink sensor that we have made can be easily calibrated to adjust itself to the ambient light settings using a 10K potentiometer. As we will show, the device responds very quickly and can detect a closed eye state in a matter of microseconds.
close, open, close, open, close, open, close, open, fast close, fast open.
Now we test our device to detect the closed eye state of the driver using the eye blink sensor which we have developed. The IR sensor values are constantly printed on the serial terminal of the PC. The device is in a ready state and is constantly monitoring the IR values. The GSM module will send a missed call to the driver's phone the moment the alarm sequence is initiated to give him an opportunity to wake up and dismiss the alarm. Now the driver's eyes have been closed, and the moment that eye blink sensor detects that they have been closed for an extended period of time, the alarm sequence will be initiated. Now that the alarm sequence has been initiated, the missed call will be sent to the driver's phone to give him an opportunity to wake up and switch the alarm off and hence escape the alarm sequence. The missed call is sent from the GSM module of our device. The driver can now push the button and switch the alarm sequence off. We have used an MMA 7760 3-axis accelerometer to detect the tilted head state of the driver, which generates X, Y, and Z values for the accelerometer. We have also devised an intelligent algorithm to detect the tilted head state. Firstly, our device auto-calibrates itself to detect the reference X, Y, and Z values for the position the driver is in the moment the microcontroller is reset. After this, deviations from these reference values are calculated for each head state. The moment a significant deviation is calculated, the head state of the driver is monitored for 6 seconds, and if the head is found to be at rest for an extended period of time, then the alarm sequence will be initiated. Now we test our device for the detection of the tilted head state of the driver. As can be seen, arbitrary motions of the driver are not being detected, which is important as the driver needs to be free to do as he pleases while he is driving. However, when the driver's head state is at rest for an extended period of time, as will be shown now, the alarm sequence is triggered. A missed call will be sent using the GSM module to the phone of the driver so that he has an opportunity to wake up and hence shut the alarm sequence off. The procedure is repeated and the head tilt state of the driver is again detected. As can be seen, the arbitrary head motions of the driver are not being detected. The driver is free to do as he pleases while he is driving. However, the moment his head rests for a specific amount of time, the alarm sequence is again triggered. The help signal, which is present outside the car, alerts the vehicles around that the driver is in an alert situation and needs help so that they can protect themselves. A missed call is sent to the driver so that he has an opportunity to recuperate and shut the alarm sequence off.